Oh, you got this. Okay, I don't know how you control or do any of that. So. Give me a second to make sure. Okay, it says it's there. Oh, there it is. And the question is, does it have a volume to it? Here, no volume. I don't even know where the volume. Oh, oh, there it is. All right. Let's see. Did it not come on yet? Well, that's weird. The remote is dead. Now, there's no. Oh, they got the webcam faced at you. Okay. Well, let's see. Why will the projector not come on? Here we go. It's always a joy a minute here. I still don't have much faith that it's going to come on, but I see a lit bulb there. Okay, now what does this do? Okay, like, I don't know how anything. Okay, at least we got a screen there. Let's go with that. Okay. There's that. No, it's gonna just go in. All right. And this is really strange. So on the screen, it picks it all up. On my screen, it does not. Okay, we're in dynamics, I hope, aren't we? Okay, so we were in the area of what he calls erratic motion, which actually doesn't necessarily have to be erratic. And let me run down. Okay, this is not a touch screen. Let me run down through, there are problems here and there are solutions, but I'm going to go down to ones that are in the, not in the back of the book, but in the problem set, which I don't know if I have to go all the way through that. Let's see. So you're gonna hear fundamental problems, is that it? And then there are problems. Okay, come on. Okay, come on. Okay, let's just go to the problems then. Okay. Okay, so we will just open a OneNote and make our own problem. Okay. So let me just, actually, this is really weird. Let's do add a page and give myself a pen. So I do not know what's going on over there. It's it is still sitting there. So, oh, the pen's not even lining up. Just cut this thing off for a second. Okay. It still doesn't line up, but I'm going to do the best I can. So if you start seeing jumps like that, the reason being is because the pen and the visual don't match up. Oh my God. Okay. Okay, how the crap do you fix this? This is, okay, I'm gonna cut it off. Maybe there's a thing here. Nope. We may just convert to the whiteboard, but I can't get the camera to line up with it. Okay, let me see if I can figure out how the, my God. Oh, well, let's see if this thing will work. Let's see. It doesn't quite work. You know what I'm gonna do? I'm gonna just project it on the screen. Now I've lost my mouse. Okay. Okay, so let's take a look. Here's a jet, okay? So there's that. I'm gonna look at the thing and see if there's a way you can control this camera. Let's see. It's not hover cam. Okay, so let's see. I don't know what. It's a camera link cam. Maybe that's it. God. I mean, what good is that thing pointing straight at me? Okay. I am sorry about this. This is half-broken technology that doesn't seem to work together, and all the remotes are missing. Oh my God. What does this do? Well, I tell you what, here's what we'll do. And there's not even a corner. Oh God. Well. Okay. So, if you have, let's say you had something that we're just going to make a problem up. I'll start with a v as a function of time. And I'm just going to make stuff up because I can't bring stuff up that. I'm just going to say the velocity goes along. This is like 50. This is like, I don't know, 10 seconds. And we'll feet per second. We'll just say it's 50 feet per second. Goes along, and maybe it's about 20. And then the guy's velocity goes back down to say, I don't know, here 30. We'll even make it go backwards. And make it minus 50. Good grief. Let's say. And we're going to turn around and we're going to want to know the position as a function of time. And then we're going to want to know the acceleration as a function of time. And unfortunately, I can't line them up on top of each other. So here, let me get this. I cut that thing off. I mean, on. So the button didn't work to control that. Oh my God. Okay. So the first thing to go to 10 seconds is, okay, so again, if you have S, V, and acceleration, if you're wanting to go this way, you know, if you have this as a function of time, you got to take a differential. If, in fact, you want to go the other way, you want to do an integral. So the thing is I'll put it right in the middle on purpose, because to go to 1, I got to do an integration to go here. And so I really don't have that. I've got a velocity on an S, and then over there, I probably should have done it the other way, but I'm going to take a differential to get that. So the first thing I'll do is, I guess since that plot is closer to this than the other, I'll do it first. So in your mindset, you can say, okay, here's the other thing. I know that's a differential, so I'll do it like this. And this is integral. So if I've got a first order, how should I do this? Maybe I'll create another one. And I'll say order. And in this case, I'll say I've got a first order. So this little part right here, I'll go ahead and break it into regions. So here's region 1, here's region 2. That way I'll have a different column here. And region 3 actually goes all the way to here. The reason I broke them into those is because here is linear, is constant, and it doesn't change. And then it's linear again. So it's linear, constant, linear. That's, okay, so the order. First order, you could say this is 0th order because a constant, you know, ax plus b, that's linear. Just b is just constant. And so I got a first order here as well. So if I'm going to concentrate and go to the S first. So if I go here, I'm going to take an integral. What happens to the order? It's got to go one way or the other. So if I'm taking an integral of, say, I'm going to make it really simple. So this is first order. What is the order of that? Did it become quadratic? Plus some sort of integration constant. So if it's first order, I integrated it, becomes second order, right? So likewise during region 1, so here's what I'm going to do. Take order, and then what I'll do is I'll do region 1, region 2, and region 3. Now, it's pretty boring right here, but it's just a way of thinking about it. Before you start working the problem, if you sort of classify things in your head before you start, makes it easier. So, I don't know. So if that's first order, I take a differential, it becomes 0th order, which means it's constant. So this just means it's constant. During this part, I look up here, so that region here's 0, so this will become first order. And I'm just going to put a question mark there. Because, well, we'll deal with that in a second. And then we're back here. So if you look at it, okay, so let's look at it from this standpoint. As I integrate this, now I'm going to start doing my integration here. So I'm integrating to get the other. And now, you know, this could be done fairly rapidly, but I'm just trying to, you know, that's my job, is supposedly to fill in stuff. So as I move to here, I multiply that out. I take 1/2, the base times the height, that's the value that gets put over here. Well, I go all the way up to here, and the area here, and I'll even just put it in here, 10 times 50 divided by 2. So that's 250, right? Isn't that 250? So the question is, does it go straight up there or does it not? The other way to look at it is, and this may be a guideline, is if you really looked at this, this would be nothing more than the slope, rise over the run, or 5, and it's t. So now if I'm over here, and I like, okay, I want to carry this out this way, and then I want to do this, and then what I want to do is integrate it, and then I want to make sure I'm integrating it from the same spot here. So there's your time is equal to 0, and this is supposed to be s at time is equal to 0, and this is supposed to be t, and this is supposed to be s at t. Does that sort of make sense? So if you put in this, which actually now you have, you got 5t integrated from 0 to t, to dt. What is that? And that 5t squared over 2. But now I have these, and now I have s of t minus s of 0. But we didn't really discuss that. There really should be a discussion of where you should start at. And I'll talk about that for about 5 seconds or so. So if I put in t is equal to 10, I get 5 times 10 squared over 2, which is like that 5. 10 squared is 100, so I get 500. This one comes up with the same answer, but it looks a little bit different in the way it got built, so to speak. But this actually should become plus 5, 10 squared over 2. Maybe I should just write that as 250. But before I write that, what you have to realize is that's the value right there. But what happened getting there? Well, actually what happened was not a straight line. I don't know how curved to make it. So this becomes, well, 5 and 2 is 2.5 times t squared. So you put in t is equal to 0, then you start moving to the right, you get some sort of parabola looking thing like that. Does that all kind of make sense? So you could visually see the page and then just kind of do it, or you could carry out the integration, but the erratic motion is kind of, if you have to give a quick answer, you can just sort of multiply your areas and figure it out. I used to give on tests. Now the test is going to be just a mimic of the problem that's in the book. So I'm not going to be giving tests anymore, but in my mind, what I used to do was pick specific spots and say, oh, well, at 15, what's the position, and what's the velocity, and what's the acceleration. I don't do that anymore because I'm not going to do that. I'm just basically everything, you go take and work a problem with set homeworks, and then you go back. And then for the quiz, it's just going to be a couple problems that are actually from the homework. So, okay, so what do you do? Okay, I didn't bring this up, but I left it on the table because now I'm going to go down region 2. Now, there's two ways you could look at it. One is, okay, I know, you know, I'm not going to have like a transporter machine. I know if the little marble or whatever this stupid thing is here at 250 at t is equal to 10, it's not going to all of a sudden at 10.00001, it's not going to be like way over here. So it's going to start here. This is a constant. If that's a constant and I'm integrating a constant, I've got to get some sort of linear function now. I don't know, okay, 20 seconds. I don't know what the value up here is, so first I'm going to do it using just observation here. I know I got 250 here, so maybe I'll replace that with 250. And the next thing I'm going to do is look at the area here. Well, that's 10, and that's 50, so that's 500. So this is not scale, obviously, because here, let's do this, 2.5t. This plot may get out of control pretty quick. So nothing's to scale, so this is 750. So I was at 250. My velocity remained fixed at 50. And so as I went through time, I just do a constant velocity. You know, if you look at it, it looks like a slope. If I take the derivative of this, I'm going to get that. So actually, if you wanted to, you could say the slope here is equal to rise over run. Okay, so if the slope here is equal to the velocity, it's got to be equal to 50. Now, what I'm going to do, did I try to cut that thing off? Here, let me do that again. High tech. Go away. Oh, it's not even doing it. Wait. Oh, there we go. Oh, my God. So, let's do this the longhand way. And what I'll do is I'll give this and move it over there. The longhand way is, okay, I'm doing the same thing that I did here. And so I'm integrating. Okay, I'm integrating from here. They got plenty of those around here. From ds v dt. Now the question is, I'm actually integrating this from 10 seconds to some t as long as t is less than 20. So here, let's do it this way. 10 to t for t less than 20. It could be equal to 20. So I'll say less than equal to 20. So this has got to be S of 10. This is one thing that he's not real particular about in the text that he should be. So then this should be S at t, the same t that's right here. So on the left side, what you get is S of t minus S of 10 equals to, now I've got to put this in. And the velocity is just 50. So if you don't mind, I'll just slip it in there. It's 50. Here, I'll do it this way. Because what I'm going to do is I'm going to take a picture of all this. And since there are a few people that are not here, I'll start posting things on Twitter, as well as maybe what I'll do is I don't know. I'll try to figure out what I can do. A ball peen hammer might do a good job. So 50, if you integrate 50, you get this, evaluated from 10 to t. Now, 50t is just 50t, and then that's minus the 500. Now, think about this for a minute. Stare at this, and stare at this. What is, okay, that is just 500, so that's just 500. There's nothing more you can say about that. What is this? What is the position at 10? Position at 10 is equal to 250. Now, sometimes they'll put the 250 in right here, but really you should carry it out this way and sort of look at it. So if I move this over to the other side, well, let me just do it. Minus 500 plus 250. That brings me back. Well, okay, I'll do one more step. Now, let's stare at that for a minute and let's think about it. Now, unfortunately, my scale is off. So what I'm going to do is try to do a halfway repeat of this diagram so you kind of see what's going on. Let me try this. I'll do it smaller. I go a certain distance. I go twice that distance. It's 10 and it's 20. So I go 250, and then I'm going to go 750. Okay, so I'm going to do here. Okay, so this 250 plus 250 is 500, and then another is 750. I say this, but I'm not sure I can do it justice. So move out here to 250. Does something like this, and then the end of this is going to be up around 750. Okay, so there's what I was trying to do. Now, and this is the intercept of that line. And you notice it's minus 250. So this is minus 250. That's why it wouldn't work here, because if you did that, your intercept would be, if you just took this back, it'd be right here. This is not the scale. You can't do that over here. This is a terrible scale. I didn't realize that when I started doing the problem. So in fact, you have that. So the key point to pick up here, I think, that is weak in the book is this, and how it's tied to that. And this one, and how it's actually tied to that. They have to be the same. They have to be, in other words, this is T, and this is S at that T. This is 10, this is S at that 10. And that's something you got to keep up with, something that they kind of... Now, the next one, the next state has a velocity. Yeah, I'm going to just go ahead and start. It's been so long since I've used the Twitter site in a few years. But here, I'll try to post it real quick. It may not even show. Oh, there it is. It used to make a funny bird noise when it got posted. It doesn't make my bird noise anymore. That's been years ago. Well, here. I'll go take a picture of the other one too. Do that. And there it goes. And if you go to, it's kind of a weird thing if I twitter.com dr Fitland, you'll find it. There's old tweets. There's a big gap in there because I was doing YouTube. And then I get more exercise today, so maybe if I could figure out that camera, and just, I mean, maybe this is what I'll do, is I'll get up and walk around. So, okay, so the next phase is, okay, this thing, the S, we're still out here at whatever, but if you start slowing down, you're still increasing, you're still going to the right. What happens when you reach 30? Yeah, what happens is you get out here, you slow down to 30, and then it just so happens. So this is not really putting on the brakes. This is like throwing it in reverse. And your tires are spinning backwards, and then pretty soon your velocity is going negative. So you go out here to 30, reach a spot at 30. You know what? Instead of this picture, maybe I'll do this picture, since I actually tried my best to make the scale okay. So what is happening to you is your position is still increasing. Now, let's go ahead and instead of trying to interpret this, what I'll do is I'll interpret it back to 30. And then I didn't say, so let's just say it goes to 40 here. And let's stop the problem. So, let's do it mathematically first. Mathematically, I have to figure out the equation there. So, at first glance, it might seem difficult until you realize it actually isn't that difficult. If you recognize that any two spots you can pick up, I don't know, 30 might be a good one. So all I need is two spots. That's all I need. So if I look at this, I have velocity as a function of t for region 3 being, what is it? Ax plus b. At plus b. It's linear. It's going to have an intercept somewhere. I have two unknowns. All I need is 2 points. Okay, so what do? This is the way I approach these things. Well, I know at 20, the velocity is 50. So I can put in this, what did I say? 20. So it's 20 plus b. So there's one equation. Now, you can struggle, okay, so this is the way I look at it. You can struggle to find your slope and your intercept. I can find my slope really easy. But I can also do it this way. So my velocity at 30 is going to be nothing. So it reaches right there. And that's going to be the same A, 30 plus B. Now I can solve both of these and kind of put them together. One way I could do it. So now I have two equations and 2 unknowns. Now I can also make things easier for myself and say, really, I didn't need but one, did I? So if I stare at this, the rise over the run is equal minus 50 over, and the distance there is 10. So it's minus 5. So I can put in a minus 5 right here and solve it. So I got two, so what I'm saying is I got two ways I can do it. I can join these together and solve. Or I can do one of them and look at the slope. So here, let me join these two. Whenever you get two ways to solve something, it's a good idea to do both real quick. Just because. How can I solve this for A and B? One, I can eliminate one of them by simply subtracting the two equations. 50, 20A plus B. And then I'll take the other one, which is minus 0 is equal to minus 30A minus B. Hopefully this turns out to be okay. I don't know that. So now I add the two. This gives me nothing. That gives me minus 10, right? And this gives me 50. So now you take the A and you divide that minus 10 over and you get minus 5, which is what you got before. Okay, so this is the same way do it mathematically, that's visual, but you still don't have the B. So if you want to solve the B off either one of these, if you're doing it this way, you would take one of the equations, and I'm lazy, so I'm going to take this equation. So if I put in a minus 5 here, I say 0 is equal to minus 5 times 30 plus B. Then 5 and 30 is 150, move it over, so I get B is equal to 150, right? Now, if you're over here and you're doing it, of course you got the same thing. I don't know that it, you would take your 5 and you'd pick one of the equations. So here you're doing the same thing. So your equation you ended up with, okay, so your velocity T in region 3, and I'm just putting that down there. I mean, that's kind of a weird notation. What was it? Minus 5 times T. Is it minus or plus 150? Is that right? So let's check it out. So if I put in 20, so minus 5 times 20 plus 150, that should give me minus 100 plus 150, and that equals 50. So yeah, I ended up, so that is that point. The next thing I'm going to do is put in 30. This is just a check. It's just me checking. Put in 30 plus 150. That times that's 150 plus 150 equals 0. So did that work out? Yeah. So I've checked it and I came up with it. I checked it to make sure because I'm standing in front of you and there's not a piece of paper. I just made the crap up. So, so I'm sitting here looking at this. Now the next thing I need to do, the differentiation part is so much easier than this part. There are two ways to do it, but the differentiation is like look, see, write down. I mean, and we'll do that in a second. So here, minus 5t plus 150 in dt. Okay, now I got to make sure my limits are correct. So I got to start at the beginning of region 2. I'm sorry, region 3, which is 20. So 20. And I'm going to say t, as long as t is less than or equal to 40, but yeah, it has to be, it wouldn't make sense to integrate it to be less than 20, so it's got to go from 20, so, I mean, all right. So you're supposed to do that. So if you're a mathematician, they'll want to see that, although in your brain you know not to do that. So this, in fact, is the position at 20, and this is the position at 2. So the first thing is the left side. That's the easiest part. ST minus S at 20. S at 20 was 750. So I can write this down. Minus 750 equal to, now doing this, okay, minus 5t squared over 2 plus 150t. And then maybe put it in a box like that and put 20 in t. So, putting in a t here, see, 2.5 t squared plus 150t, as long as t was less than 40. And then putting in 20. Okay, 2.5 times 20 squared plus 150 times 20. Now I'm kind of interested. Okay, so now I've made a faux pas here. If I was on the screen, I would select this and move it to the right, but I can't do that. And so my faux pas is that. And the reason being is because I evaluated at this minus the evaluation at that. Does that make sense? I guess that makes sense. So my key is, what I want to stare at is this. And I don't have a calculator, but there is one on this phone. Let me find it. 2.5 times 20 times another 20. This thing is 1,000 minus 150 times. Why did I do that? 3,000. So am I looking at that right? Minus 2,000. Okay. So S at T. I might have done that wrong. I don't know. Okay. So did I do that wrong? This part, say. Did I evaluate that wrong?
I got negative 2,000 as well.
Oh, did you? Okay. Yeah, because I'm not, it seems like I have a problem with my Apple calculator. It's basically my brain and my fingers don't actually put the right numbers in. And so sometimes things just are not, they just don't work right. So S at T equals 2. So I got to take this thing, move it over to hit part of that one away. And so nothing's really happening here until, okay, so bring that over, so is this right? 2,000 minus 750, is that right? I hope so. Well, before I believe it, I really need to put in some values. I really want to put in T is equal to, okay, we're all in this region right here. So to me, the only thing that really can verify anything is I put in 20. And if I put in 20, I'm going to hope that in the next 5 minutes I get 750. That makes sense. So I'm checking myself. I have no guarantee that. So this is a check. 1250. Sorry. So does that number equal to, what was it, 750? I hope so. If it doesn't, I'll let you do it, because I just can't. Maybe my fingers are too big, and my phone's too small. Maybe that's it.
Same principle.
Oh, good. I was about to say, crap, I hope it is. It's supposed to be 750. So now I have an equation, no, not that one, this equation, that actually, if I wanted to, okay, first, this is hard to draw on the board. I can't figure out how to do this. I know it starts at 750. So this was supposed to be S at 20. I know it starts there. I just don't know what to do. I mean, I don't even want to think about it. It goes like this. How about that? Now, if I felt like going to the computer and typing it in, I would find that out. And that's really sad of me to do that. But here's what's interesting. Let's say we get to 30. Let's do this. Let's do S at 30. And what can y'all help me with that? 2.5, 30 squared plus 150, 30 minus 1250. And then, if you can, do one more calculation for me. And then I'll say, I need to go get a pop card. Okay, so what do you get for this one, and what do you get for that?
The middle one, we got 1,000.
1,000? What's the bottom one?
750.
750, all right. So Let's think about this back over here.
I got, 2,500 for the last one.
2,500?
Yeah.
Oh, we see 3240 on my bad.
Oh, wait. Okay, so.
Yeah, if that's the 30 right there, then yeah.
Oh, gosh.
Oh, that's supposed to be.
That's me, that's on me. That's supposed to be 40.
Oh, yeah, 750.
Okay, so let's look at logically what we see. We see the area is 250, the next area is 500, and the next area is 250. We add all those areas up, and what do we get? What's a 500, 250? Isn't that 1,000?
Yeah.
Okay. That's exactly what that is. So all you're doing, this sounds weird, but you're marching through time, looking back at the area before you, and that's your position, wherever you're at. Now you take your 250 or 500, this time it's minus 250. So what do? 1,000 minus 250, 750. So that's what you got here. So you did all this math, and this is wonderful. This, for me, it seems so weird. I mean, over the years, I'm kind of a bizarre person because to me, I can fall asleep and do the math and I can work it out. But sometimes when if I'm just having a bad day, I look at my plots wrong, I'm going to get an answer that might be wrong. And maybe that's my age. I'm just to the point where, to me, mathematics is a crutch. And it's a good crutch because I know as it crutches out, I can keep getting it working. When you're first learning it, yeah, it's annoying. So let me take all these pictures and post them on YouTube and maybe I can figure out how to get this camera to work, and maybe I can I don't know. You may just be going old style and you taking pictures of Twitter on Twitter. I mean, if it works, it works,
Yes, we do.
Yeah, we're good.
We have something. The first homework is here is due second.
All right, since the cameras did not work, nothing worked.
Go through there and you'll say, like, everything will either be, like, for participation points or the, like, you can look at it if you want to, you don't have to.
There's the pictures. 21 seconds ago, 37 seconds ago, 19 minutes ago, 19 minutes ago.